Welcome everybody to the Wednesday night Arduino show. I want to say go to YouTubeModelBuilders.com. There you can find the schedules for the shows for Tuesday and Wednesday shows. Those start at 8 o'clock Central, 9 o'clock Eastern Time. The Thursday show is at 9 o'clock Central, 10 o'clock Eastern Time. Also be sure and click on the email, sign up for an email notification when it comes out. And let's see, I don't have any kind of real special announcements to go on with, so I guess right now I'll just go ahead and turn this thing over to Chris and
all right,
let the show begins.
Thanks, Johnny.
There you go, Chris.
Here we go. All right, well, welcome everybody. If you're just tuning in for the first time, we're going to be finishing a project we started last show. So after tonight's show, if you want to go back and watch the January episode, you can find the code and actually see a working example of what we're going to build tonight. But we went through, I showed you the live example I did on my layout, and then we went through the code pretty extensively. So ran out of time, so tonight we're going to actually build a version of it on the breadboard that you can then turn into the real thing on your own layout if you want. So what it is to throw a switch, we're going to use a servo, and then the signal lights on each side of the switch, basically to indicate the position of the switch, or if it was a CTC signals that you wanted to tie into a CTC system, that would work fine too. But it's basically a very cheap way to activate your turnout and have the signal lights change accordingly. So those of you that have been here many times before, welcome back again. Glad you guys are riding along with us. And if I seem a little off tonight, it's because I'm fighting a bad cold and not on top of my game. So apologize for that. Just have to bear with me, I guess. I took some meds and pounded some Mountain Dew and should be able to make it through an hour, I think. So if nothing else, bear with me and thanks for being here. So with that, I'm going to start by sharing my screen and then we'll get to building. So if you guys remember, we've been using this website I created, the Arduino Worksite website. Tonight I left the stuff from January and added 2 more links on here, link number 4 and number 5. And if you're wondering how to get here to see this, here's the link again. It's sites.google.com/view/Arduino workshop. That should get you to this website. I'll leave it up for a minute. And if you guys want to bring up that web page while you're sitting here, we're going to be using a couple links off of it tonight. So let's give it a couple more seconds here. And if anybody has any problems getting into it, you know, just you guys out in YouTube land, just post up in the comments and Johnny will get a hold of me and we'll see what we can do to straighten it out. So anyways, that'll bring you to this Arduino website. Arduino Workshop website. Last month we had the links number 1, 2, and 3, which were basically a link to the sketch that we use for the Arduino, and then a link to a bicolor LED library page, the instructions for the library, and then the third link was actually for the library itself. These 2 links I added here, you know, why does it say joystick and serial monitor when we're working on a servo turnout? Well, because we're also going to do that tonight. I forgot to mention that earlier. Got 3 things for you tonight. We're going to build this, which shouldn't take more than about a half an hour tops. Then I talked about just doing something with a joystick real quick because I was curious myself, hadn't done anything with it, and I think if you guys are clever enough, there's different ways you can use it on your model railroad in place of a push button or other types of actuators. So I just thought we'd take a real quick look at that tonight. Excuse me. And my my brother Dave has been working on a really cool project, which we're going to start building in April, and he's going to give you a sneak peek on that. So that's our lineup for tonight. And with that, let's get building. So, like I said, if anybody has any problems getting to this website, just post up a comment and Johnny will let me know. So, all right, get back to my camera here and get this all set up for you. Well, sure, now it doesn't want to stay put. Practice all you want. Doesn't matter when the real time comes, right? All right, so what we're going to end up doing tonight is, if you remember from last month, I had two push buttons that would, you know, throw it for the main line and throw it for the siding. And we also had the signal lights that were up on the tracks. So what we're going to do is we're going to, if you have a bag of green LEDs and some red LEDs and some resistors, anything between 300 and 1,000 should work just fine. I'm going to be using 300 ohm tonight because I don't, probably 470 is a good place, average place to land for an LED, but I don't have any of those on hand. And you also need two of these push buttons. Let me just pull one out quickly. Just a four-legged push button. And I'm also going to bring up the sketch real quick because we use the sketch kind of to tell us where we need to connect everything. I didn't bother doing a fritzing diagram for this one because it's pretty straightforward. I think we've done and connected enough servos and LEDs that you could pretty much just look at the sketch and determine which pins need to be connected to what. So if you look, I gotta go. I apologize, I'm not screen sharing, am I? Told you I'm a little off on my game tonight, so apologize again for that. Screen share, where are you? There it is. So why don't we just go ahead and load this sketch up right away, I guess, while we're at it. So if you want to connect your Arduino to your computer, going back to the web page, it's link number 1 right here. If you click on that link, it's going to bring up a page that looks like this. And what you can do is, if you've been using the Arduino Create, which is their online web editor, you can go ahead and hit this button and open it in the web editor. It'll end up looking just like this. If not, you can hit the button right next to it, which is download the sketch to your computer, and then you can open it in your normal Arduino IDE. So I'll give you guys just a couple seconds to go ahead and download it and open it in your IDE, or go ahead and open it on the web editor. I really found myself using this web editor a lot. I hardly ever use my offline, you know, hard drive version of the IDE anymore, just because it I like all the extra little bells and whistles that are in the online editor. It really works out nice. So while you guys are doing that, I'll just kind of skim through here a little bit and show you for the push buttons. You notice right here we have the button pin 1 and button pin 2 equals 10 and 11. So that right away tells us that one of those push buttons is going to go to pin 10 on the Arduino, and the other one is going to go to pin 11. So if you're already caught up and working, you can go ahead. I'm going to stop screen sharing for a moment. Go back to the camera. Just as a refresher, the way you install these is, you notice they got kind of the legs kind of curve out on each side. You want to put it so that when it spans the center joint of your breadboard, that the curved legs are like that. Hopefully that's showing out pretty good on the camera. So that's the correct way to install one of these push. If you try and do it the other way, first of all, it's not going to line up with the holes, and you're going to end up bending your pins to make it fit. That's a good clue that you're putting it in 90 degrees off from the way you're supposed to. The other way I remember is that it's kind of like wider between the pins one way than it is the other. The wider pin is the wider distance is the one you want to use to span the center of your breadboard with. So just a little hint to keep you on track. So what we can go ahead and do then, I'm just going to grab me some jumper wires here. And if you remember, we were just talking that button pin 1 goes to pin 10 on your Arduino. So pick one leg of your push button. Make sure you line up in the same hole. I'm going to grab a longer jumper here. That one's kind of short. Let's try that again. I'll make sure I'm lined up in the right hole, and then just go to pin 8, 9, 10 on the Arduino. Let's get that back in the camera a little better. Then I'm going to do the same thing from the other push button. Make sure I get it in the right hole here, because it's not going to work if you don't. And send that one over to number 11 on your Arduino. So I can get that camera up and out of the way a little bit. Yeah, I guess it was better this way. The only other thing we have to do on these push buttons right now is ground them. Because of the fact, if you remember our talking last time, that we really don't need a debounce on these buttons because of the delay I had built in, as Dave so eloquently pointed out to us. All we're going to do is go to the other leg on the same side of the breadboard, run it to your ground rail on your board, and do the same with the other button. Okay, you guys see that okay? And then of course we're going to need to run the ground wire back from the ground rail back to the Arduino. So I'm just going to go back to the far side of the breadboard and run it out to the ground pin on the Arduino. So now basically the push buttons are all attached. If I push these, they would function, only there's really nothing else hooked up for them to do at this point in time. If I have them hooked up correctly, it should function, I should say. I'm just going to make sure I uploaded my sketch. I was telling you guys to do that, and I don't know that I did myself, so I'm going to, without sharing the screen, I'm just going to go ahead and go out to my IDE and upload the sketch. And there we go. So I'm actually thinking I might have something wired up wrong here. Because if you remember right, let's switch back to my camera. Oh, there it is. Okay. See this built-in LED light? There we go. Off, on. Okay. It's the 3-second delay that's throwing me off. That's my little test. Remember I told you I used that LED, built-in LED to just be able to know which button was pushed last. That's a good test to make sure you're working right now before we even hook up the rest of the LEDs or the servo. What happens is if you push one button, the light should go off, and then you have to wait at least 3 seconds because of the built-in delay in the program. Then hit the other button and it should come back on. So I'm going to turn that, you can see a little better. I hit the white button, LED goes off, wait at least 3 seconds, hit the yellow button and the light comes back on. So there's a little built-in test right there to make sure you got your push buttons wired correctly. If that light is not going on and off, then you don't have your 2 push buttons wired correctly. If you have any trouble with that, just jump in at any time. And if you guys want, there's plenty of room in the panel tonight. So if you're building along with us and you want to jump in here, I think Johnny posted the link. If not, he can put it out in the comments on how to get into the room. So feel free to jump in and join us. If you're building along and you want to be able to get some live help, that's what we're here for. So that was easy enough. Now the next thing we're going to do is go ahead and connect our servo. I just happen to have this one is connected to a mount, but you know, it's just a typical servo. The rest of the blue thing is just a mount that I have. If you remember right, these are fairly easy to hook up. I happen to have the orange, red, and brown. You might have white, red, and black. They'll be in approximately the same place. The white would be where the orange is, the red is where the red is, and the black would be where the black is. On these, the center is the power. The red goes to your power, and then what they do is they make the black is the ground, and the other one is your control wire. The reason they put the center power and then put the other 2 on the outside is if in case you hook it up backwards, the end 2 would be swapped. It doesn't hurt anything to swap your control wire and your ground. It would hurt something if you accidentally plug the power in to the wrong thing. So they kind of make it goof proof that way in case you put your wires on backwards. So we're going to take the red wire and connect it to 5 volts. So look on the side of your Arduino and find the 5-volt pin. I think I missed it. 1, 2, 3, 4. Oh, yeah, I did. Okay. And then take the black and go ahead and you can either put it in the other ground on your Arduino or run it back. Whoops. Sorry about that. Or run it back to the ground rail on your breadboard. Either way, I'm going to go ahead and connect mine right to the Arduino to the second ground pin. Don't be surprised if you hear see your servo jump once you connect the power. Now, in order to figure out where to put the control wire, we just go back and look in our sketch. So I'll do a screen share real quick. And we'll bring up the sketch. And right here, servo pin equals 12. So that tells us that we're going to take the control wire and put it on pin 12 in the Arduino. So I go ahead and do that. So now I have wires in 9, 10, 11, and 12 over here, and I've got power and 2 grounds on this side. Okay, so we got a question. Go ahead, Johnny.
All right, we got Nathan over here. It says, can you do it with railroad crossings? Use this for railroad crossings.
Well, certainly. I think you could literally use this for anything. They heard that question, right?
Yeah.
Or do I? Yeah, okay, I don't need to repeat it. Yeah, so not only could you use this for a railroad crossing, you could use it for semaphore, anything that you think you could actuate a servo from. You could do some slight modifications to this sketch, and it's just be a matter of changing the throw. You know, this would be real easy. In fact, it should work right now. I'm going to go ahead and push the button. You see it went one way. Push the button, it went back. Wait 3 seconds, push the button. Now, if you wanted that to be like a crossing gate, you might have to change the amount of the throw, but it would certainly work just fine. In fact, you could even add a second servo into the sketch real easily just by copying a section of the sketch and pasting it back in. Let me show you real quick. screen share. Bring up the sketch. Of course, you'd have to add another servo right here. You know, servo pin equals, you know, give it another name, and they have to be like 13. Might want to say servo pin 1 and servo pin 2, like I did with the button pins, since you now have 2 of them. So first define it, and then just go down in here, and everywhere it's telling you what to do with the servo, like attach the servo, write to it, delay, and then detach it. Just copy that in and paste another piece of it, you know, right in here. In fact, I'll do it and then undo it.
I just want to point out, Chris, you don't really want to use pin 13 though, because you've got the built-in LED on that.
Good point. Very good point. So just by pasting another copy of those same instructions, or you could even stick it in the middle here between the attach and the detach, you could just make one go one way and one go the other way just by changing this to say diverge instead of straight. Or you could call it up and down if you're doing crossing gates, if it helps you, you know, keep it straight. But the point is, once you've played around with a little bit of code, you know how easy it is to just copy and paste a second servo in here and have 2 servos controlled at the same time. The other thing we could do while we're kind of on that subject, and I'm going to
real quick, is since you're not going to use pin 13, you could drop down to pin 8 or 9, right, for the second servo?
That's correct. The only thing is we'd have to look up here and see, yep, because we've got button pin 10, 11, and servo on 12. And then down here on the LEDs, you see I have 2, 3, 4, 5, 6, 7, 8. So we may have to pick a 0 or a 1.
Yeah.
We're actually running out of pins on this thing just because of the fact that I have so many LEDs connected to it. But all you do is find the one you
You could also use one of the analog pins, though, Chris.
That's true too.
You got 6 analog pins on the other side there that you could use.
Yep.
Yeah, because servo's basically analog anyway, right?
It is, but it doesn't have to be treated as an, you know, the analog pins don't have to be used as analog. They can be used as straight digital, I believe.
Well, I think servo is more like PWM, isn't it, or not? Or am I wrong? I might be wrong about that.
No, when you're defining your servo pin, I think your servo pin. No, I don't think so. I think it's just a
straight digital.
Yeah, it might be a straight digital. It's not
because it's on straight digital, just on or off. Yeah. But we're here. No, sorry. Go ahead.
I think the servo library pulses it manually. It doesn't need to be a PWM pin.
Oh, okay. That would make sense. I could see that.
And that's why you could use the analog pins as well, because they're not necessarily PWM pins.
Okay. The other thing go ahead, Johnny. Got another question here, I guess.
Yeah, we got another question. DDA40X man. He says, I'm just getting started. I found Arduino starter kits on Amazon. Should I get the Uno or a Mega for expansion capability?
Functionally, they'll work about the same. And actually, if you're building something like we're building right now, a Mega would actually be kind of nice because we're running short on pins. If you had a Mega, you could literally do 2 turnouts and probably get away with it. There'd probably be enough pins for 2 servos and all the extra LEDs for another whole turnout.
Yeah, so the Mega's just got more pins on it than the...
Yeah, functionally it's very similar. There's hardly any difference. You know, functionally it's just a bunch more pins.
You will need to be aware, though, that there are some differences in the pin numbers, and they don't necessarily line up. For example, in the Uno has pins, like 11 and 10 that are defined as PWM pins, and that may not be, I don't know offhand, but it may not be the same on the Mega.
Yeah.
Which brings up another point. I was just playing around. I found a very interesting chip out there that's Arduino-like chip, and you can program it with the Arduino library. It's called, they call it
let me stop screen sharing and we'll let you show it to them here.
Okay. I've got this chip here. This is called the blue, they call it the blue pill, or STM32. It's actually, it's only about the same cost as a real cheap Uno. So it's about $2 or $3 for this chip. But it's actually a 72 megahertz 32-bit processor. So it runs about 10 times as fast as the Uno will. And it's got many, many more pins on it. It's got the pin equivalent of roughly the Mega, and a whole lot of additional functionality. So if you're looking to get a more powerful chip, or one with a lot more input outputs, you might want to look at that STM32 or blue pill, and you could still program it with the Arduino environment.
Just a matter of if you're going to find a starter kit with that, might be kind of tough. But no, I'm glad you're jumping in here with us, and we're on here every month, and you can even email me if you got questions, mrltrains@gmail.com. I'm glad to have you join us. If you didn't get that starter kit, go ahead, and the more parts in there, the merrier, because you're going to find that you just enjoy trying all the different parts that are in there. I know I did, so that's what got me doing this. So, okay. So back to, let me screen share again here. I'm getting all mixed up
Chris,
again.
One quick thing. A few minutes ago, we were talking about the crossing gates. Just a reminder that a number of months ago, was that maybe 6 months ago, we did a big thing on crossing gates already. And you might want to go back and take a look at the crossing gate stuff that we did. Was that 6 months ago?
That's a great comment. Yeah, we did do actually at least 2 shows. We did something with crossing gates. Those would have been probably early in 2017. If you go back to some of the earlier shows, maybe the 4th or 5th show, just go back, watch all the old episodes. We had a couple really neat examples. Dave had a little mock-up built, and so did JD. Had some pretty cool little mock-ups built. We had a lot of fun with it. So by all means. Oh, okay. Gotcha. Okay. Johnny's talking in my ear again, filling me with some good information. So just, it's go to the YouTube Model Builders channel, and it's the Wednesday night Arduino show. You'll find playlists. You'll find there's a playlist with all the shows that we've had on here so far. So, okay, so kind of that whole crossing gate question, and when I got into thinking of 2 servos, because you'd probably have 2 crossing gates, also made me realize that you don't necessarily need to have 2 push buttons. You notice in my sketch we got push button 1 and push button 2. I did work out some code in a previous episode where we were throwing a servo with just 1 push button, so that each time you push the button, it would throw back the opposite way. The only reason I went with 2 push buttons on mine is because I don't have to guess what position it's in. Even if I'm looking at the signal lights, let's say I just want to walk up and push a button, I know if I hit like the white button, it's going to be mainline, the yellow button, it's going to be diverging. Whether it was already set there or not, I know it's going to go to that position. It's either going to stay there because it was there, or it's going to go there. If you only have 1 push button, you're toggling it, so you don't really know. If it was in the position you already wanted it in, and you push the button, then it's going to change to the position you don't want it in. So this way, I just knowing which button is which. And if you remember last month's episode, I had red for the diverging route and green for the main line. So I always know I just walk up and hit the green button if I want it lined for the main. So I don't even have to look up at the signals. I just hit the button that I want for the route that I want. So you, by all means, you can use just one push button instead of two. That's another minor modification to the code. If you don't care to use two push buttons, that's easily accomplished, and I'd be glad to help you with it. Or if you go back to the show in the sketch, you could pull snippets out of the code from the show where we did a single push button to throw a servo back and forth.
It would also work if you used a toggle switch with a little bit of modification to the code.
Yeah, absolutely.
That's the advantage of learning a little bit about the Arduino is being able to just modify the code to make it fit your needs.
All right, so we've got the servo hooked up now, and as I demonstrated, if you guys have hopefully got guys building along, you'd be at this point. If you look now, when I push one button, nothing happened because it was already in that position. I hit the other one, it moves. And that LED lit up on my Arduino. Push it back, wait the 3 seconds. So at this point in time, it really didn't take much, just these two push buttons and a couple wires and 3 wires on the servo. If you didn't want to do LEDs, you know, signals on your layout, you're done. All you gotta do is go mount this under your servo and then adjust the angles like we did in last show. We covered that quite comprehensively last week. It probably bored you guys to tears with the programming, but at least you have a great reference to go back to now. Once you get this up and running, just go back and watch that show, and I think we covered it thoroughly enough that you should be able to do it without any problems. So so if you don't want the signal lights at this point in time, you're done. Now if we want to start adding some signals, I'm just going to grab all the goodies here, green LEDs, red LEDs, and some resistors. Now what we can do right now is I'll just kind of lay these out the way I had them on my layout. If you remember on the single track coming into the turnout or facing point, there was one signal that had, actually, you know what, we're going to need a whole bunch of LEDs. Remember, I just realized the ones I have in the signals were bicolor LEDs. In other words, both of these LEDs would be in a single light. It looks like a single bulb, but it actually contains both a red and a green LED. So we have to use 2 LEDs to simulate each searchlight on that signal light. So that could be the lower LEDs on my facing point route. Then I'll put in another set of them just beyond it. Hopefully I'm getting the legs all the right way here. We'll find out later on when they don't work. So this could be the upper head on that same light mast, if you will. Then when you go to the other side of the turnout where you have the two legs of track, so to speak, we have another signal on the main line. So we'll put in a green and a red for that. I wish there was a better way to do this because unfortunately I have to jump the gap with these LEDs. It'd be nice if we could lay them out a little better, that it made more sense, but we're just going to have to put them all in a line. And I'll do one more set for the diverging route, or the siding, if you will.
A little bit later on, I'll show you my example. I actually have the bicolor LEDs up and running, so we'll show you that a little later.
So if you remember from last month, if you were watching, we actually had 8 LEDs total. Even though it was only 4 signal heads, it's 8 LEDs. Well, that's our 8 LEDs now. We got 4 reds and 4 greens. So this first 2 at the bottom, in fact, let me just put those right next to each other just to make it easier to understand that that's an entire signal head by itself. And then I'll just move these over a little bit. Give you guys a little time to catch up to me here. Now I got a wire blocking my way, so I'm just going to go move him over there. So now when you look at it, let me find my little pointer stick instead of my fat finger in the way there. So these two would be the upper head, and these two would be the lower head on a single mast. This could be our main line on the trailing side of the turnout, and this could be our siding on the. So there's our 8 LEDs. The only thing we really need to do now is put in the resistors and then ground, and just complete the normal circuit you would for an LED, which is to ground them after they run through a resistor and then connect them to their proper control pin. So what I'm doing now is I'm just pulling out a bunch of my, I'm going to end up needing 8 of these resistors. Yeah, actually I'll put them on this side here. And there is a proper side, if you will, for the resistor, but it's not absolutely necessary. It will work on either side, whether it's the positive or the negative side of an LED, or the anode or cathode, if you will. So what I'm doing right now is I'm just putting one resistor from the LED to the positive rail on my. Remember, over here I have on the opposite side is where my negative rail is. I'm just going to use this for my positive rail over here, the red one. So now it's just a matter of putting in 8 resistors and making sure they line up in the right holes or the right rows that your LEDs are in. Doesn't matter once you get to the ground, to the power rail, which hole it goes in, but it definitely does matter that you're in the same row going across here as your LED is in. One of these days I'm just going to take the time to trim down all the legs on these LEDs. I use them over and over on all my different experiments, and they're always too long. Maybe one day I'll just go ahead and cut them all down. I'm going to pull some more off of here. So I've got 4 in. Anybody got them all done already? No, I'm not Speedy Gonzalez, so but Johnny Lightning over there has got them done already. Hiding in the background there. He cheated. He knew what I was building, so he worked ahead, which is fine. That's what I want you guys to do. I love it. I love it if I'm the last one done. Then that means a mission accomplished. I've done my job.
By the way, I just wanted to point out for everybody, there's lots of different types of electronic devices and stuff like that you can get. Johnny, why don't you throw up my camera here for a second? You see Chris is using 8 resistors right now, and you'll see on my board that I'm actually using this little thing. It's called a SIP resistor, SIP, which stands for single inline, I don't know what this P stands
Package.
for. Package, thank you. It's actually like 8 resistors in one. There's a grand total of 9 pins on it, so you can take 8 inputs that get grounded, and then there's 1 output pin that goes directly to ground. And that's what I'm using on my my LEDs, just to simplify the wiring and keep things a little simpler. That's all.
Awesome. Show off. No, that's great. I love that information, because he's done and I'm still pounding away here. So
well, I was done at the beginning of the show, so sorry about that.
And I actually I actually did what I like to do for this show is, it was, 2 months ago that I built that other one. And I actually was building this basically from memory, and I did not practice building another one. I just kind of, it helps me feel like a beginner again, especially when your memory's as bad as mine. Two months later, it's like doing it over again for the first time. So I actually enjoy purposely not going back and trying to figure out what I did so that I'm working through it. And I may make the same mistakes you do that way, and then it's like, okay, if I'm making that mistake, then somebody else is probably making that mistake too. And then we can all learn from that together. So the cool part is just looking at the sketch, I pretty much remembered right away. I mean, I know that I have to have a resistor with an LED. That's pretty much automatic. And we've connected the servo so many times to different projects that we know what the 3 wires on that do. And the same with the push buttons. The only way it would have got a little more complicated, and I would have had to probably look something up, is if I would have put a debounce circuit in the push buttons. That adds a little bit more. Right now, the push buttons are super simple. It's just power in and a ground out, So anyways, I'm actually gonna, now that I'm talking about ground, I'm gonna change this around just to make it better for the camera. I'm gonna get these wires out of the picture here on the ground. Swap my ground over to this rail. All right. I was hoping that would, yeah, still got the wires in the way. I guess it doesn't matter a whole lot. So anyways, we're almost done. All we need to do now is get 8 wires to connect the LEDs to the appropriate pins on the Arduino. So let's just take a quick peek at the sketch. So coming right back down here, remember we talked about this extensively last show, but we'll just real quickly recap it. Main trail is pins 2 and 3, and the main trail was my way of saying it's the main line on the trailing point side of the turnout. So that tells me that that's going to be, well, I'll show you in a minute. So side trail is the siding on the trailing point, and that's 4 and 5. The face straight would be the facing side, in other words, the straight inside of the turnout, and that's 6 and 7. And facing diverge would be the lower signal on that same mast to tell you that you're taking the siding, and that's 8 and 9. So I'm going to stop sharing. You guys can look at your code. I'm going to just let you watch me wire while I toggle back and forth and look at those numbers, but you'll have the ability to do the same thing. So what we do is taking a quick peek at that. Okay, we'll start with the main trail. In other words,
Chris, I think one thing you're going to need to do is you ran the other end of the resistor to the positive side, right? To the red rail. I think you want to run that to green because you're going to be taking your power off of the Arduino when you turn the lights on. So your resistors have to go to the ground side.
They do have to. Okay. I was thinking it didn't matter. I mean, there's a proper one, but it's not 100% necessary.
No, it's just the other, right now you have it on the red rail. You want to put it on the black rail or the blue rail.
Well, I guess I could now that I moved that rail over there, but
yeah, you could do that. Yeah,
right.
Change the red rail to be ground.
But I thought it doesn't absolutely. The resistor doesn't absolutely have to be on the anode or cathode side,
because your output pin, when your output pin gets high, turns high, if you have the other end of the resistor going into the high also, the LED is not going to light. It'll light when then it'll, actually it won't light at all because you're not, you don't have the pull-up resistor on there, or output pull-up.
All right. Well, we'll try that. What I did was I just, I went over here and I moved all my ground stuff into, it was easier to move these 3 wires than these 8
Yes.
resistors. So even though it's the red bar, I'm going to use it as a ground. So yep. Then what I did was I connected my ground back to the Arduino. So now everything on this side, all 8 resistors and my 3 push buttons, and then the ground going back to Arduino, they're all in this same red strip right there. So then what I'll do is I'll come back on this side and make these the ground. I mean the positive to the pins. Yeah. So
positive to the pins, yeah.
So then I already did that by setting that. I'll use the red just to make it easier. So all I would do is just take 8 of these short little ones, and like I said, just taking a quick peek at my sketch again. The main line on the trailing point side is 2 and 3. So we're going to go ahead. That would be this one right here, our 3rd set from the bottom. If I get my fingers out of the way, 1, 2, 3. This set right here. So I guess gotta trace that back and just put a jumper in. Actually, no. Never mind. So I don't even need this positive here anymore, do I?
Nope.
Well, what I do need is longer wires, or I'm going to have to move my Arduino a whole lot closer. So I took the green one, and I'm making that number 2. Take the red one. Sorry if I'm slowing down. I'm just running out of gas here. My brain is going mush. My head feels like a football. Yeah, that's what I was wondering. Because I've got when I set mine up, all the long legs are on the side with the resistor. And all the short legs are on the side with the pins right now. So is that going to make a difference? All right, that's a good idea. So let's test it. So yeah, nothing's lighting up. Something should have lit up there and it's not. So all right. Yep. So now what I have to do is I got to take all my LEDs and turn them around 180 degrees to make them work. And I'm just going to start with one set just to show you, just to test that it actually works before I turn them all around. Rookie mistake. All right, let's test it. There we go. We got a green light. And I know why we're not getting a red light, because I missed the resistor, hit the wrong hole there. After I moved the LED, I put it in a different hole than the resistor was in. So I got a green light, and when I hit the button now, I should get a red light. And I do. Thank you, Bob. That was help. So now I will turn these other ones around, and for those of you guys that are obviously, working along, just if you stop and test it like that, after you put your first 2 connections in, if you get a red and a green, when you push your buttons, then you're in good shape. Just finish wiring them up according to the correct wiring pins according to the sketch. So I'm just taking a second here to turn mine all around, and this time make sure we get the resistors in, or get it in the same hole as the resistor. Why is that one being a bugger? Oh, there we go. The leg bent on me and I didn't see that. It's like, why are you not lining up, dude? There we go. Then I'm just going to peek back at sketch, and we'll do side trail as 4 and 5. So side trail would be the siding on the trailing point, which are going to be these two for me. And you can name those anything you want. If that's confusing to you, be my guest and change the names in your sketch to whatever you makes more sense to you. There's no science in it. It's just whatever makes the most sense to you. So I went from to 3 and 4. So now, because we know that these are the, you know, if you have a turnout, you got like a dentist. So you got the 2 tracks on one side of a turnout, and then the other leg goes straight out. So we got a signal here and a signal here. That's these 2 sets. I'm just going to try and turn it a little bit so you see the difference between the red and the green, because I know the camera's kind of washing that out a little. So this is exactly the way it should be. One should be red and one should be green. And then when the, because obviously if you're coming in on the main line and it's lined up for you, that'll be green, and the siding should, if you're sitting on the siding, that should be red. So now when I switch, oh, one of mine failed. I probably hit the wrong hole with either the, oh yeah, resistor missed when I missed with the LED when there it is. So now I got red, green, push the button and they flip-flop the green, red. And the servo's throwing. So those are your 2 signals, your 2 single head signals that are on the main line and the siding. Then all we had to do is wire these up, and that would be the double-headed mast that's on the facing point side of the turnout. So I just need 4 more wires. And where did they all go? Here they are. Need some shorter ones. So one thing I recommend is, you know, just go ahead and buy a whole boatload of these jumper wires. I didn't buy enough of them, and I always struggle to come up with enough of them when you have a couple projects laying out at the same time. So just go ahead and
agree with you 100%, Chris. I have got more and more of those. Every time I go out and online and buy some, I usually buy more jumper wires too.
Yeah, you can't have enough of them, I think.
They're dirt cheap. You may as well get a truckload of them.
That's the only difference between jumper wires and locomotives, is the fact that jumper wires are dirt cheap and locomotives aren't. Otherwise, yeah, you can't get enough of them. You'll never have enough locomotives. You'll never have enough jumpers. But, all right, so looking at my sketch, facing straight would be the main line through the turnout. So that's going to be 6 and 7. That'll be the top of our signal head. So I'm going to go ahead and connect that to 6 and do the other one to 7. That's the top of our signal head. And I apologize, it's going to get harder and harder to see as I keep adding more wires. But so now, before I do the last one, I just want to check to make sure that I actually got those 2 connected to the right one. So if I'm looking at this right now, let me bring up I got to look at the camera again to make sure you guys are seeing this okay.
Yeah, it's kind of falling off the bottom of the screen.
Yeah, I was looking at my sketch, so here we go.
Nope, the other direction. The other way. The other way. There you go.
There.
Yeah.
Trying to get you,
that's
babe.
better. Yeah.
Okay. So down here is the one I just hooked up. This is the top head of the main line. And so that's saying red, which tells me we must be lined for the siding. So if I look over here, this was my main line and that's my siding, and the siding is red. So I've got these two wires flip-flopped. So all I'm going to do is just change those two around. And this is where, if you remember last month, I showed you when I bought that little screw terminal adapter for my Nano. That's where this comes in handy. Because now once you're making sure that, you know, which one is 6 and which one is 7, which you don't really know until you hook it up, which is going to be the red and which is going to be the green on that bicolored LED. And the same thing here when you're using two individual LEDs. So it really comes in handy to use a screw terminal and not solder the dumb things on. With an Uno, we got all these nice little things to plug into. You don't have that on a Nano. So I bought that little screw terminal adapter, and that allowed me to experiment until I got them set right. So now we've got green for the main, and way up here we got green for the main, so we know we're lined up on the main. Here we have red on the siding, so when I hook up the next one, I want that to be red. And we know that 8 and 9 are the last two pins we have available, so I'll just go ahead and hook up one of them to 8 and one of them to 9. And see, that one lit up green immediately, so that tells me wrong one. So I'm just going to move that over to 9 right away. Plug the other one into 8, and my red light should come on. And there it is. So now the two sidings are red, and the two mains are green. Perfect. Push the button. And now the two sidings are green, and the two mains are red. Yeah, if I can do that, it's kind of push the buttons one more time. So now we got two greens and two reds, two reds and two greens. So if these were actually signals, and you know, you don't even need a bicolor. If you're using the newer, I don't know, what do they call them, the hooded type, where they are actually individual bulbs for each color, this would be perfectly appropriate. The only thing you'd want to do is add a third one in there in between for your yellow, because usually there's 3 colors on the color lights, red, yellow, and green. So you could easily modify the sketch to just add that third yellow LED, and away you go. You got a 3-color hooded signal light instead of a single bulbed searchlight. The searchlight being just the round single head with a single bulb in the middle, and it can be any one of 3, 4, or 5 colors, where a color light is actually an individual bulb, separate bulb for each color. You see them stacked up, you know, like vertically, green, yellow, red, or whatever they have set up.
Now, one thing I did want to say is I know that bicolor library that you're using in this sketch supposedly supports yellow, and yellow is obtained by alternating between green and red. You're
Correct.
Supposed to get out yellow, but I tried working with it and tried to get it to come up yellow on my bicolors, and I saw no difference. I could not get it to work.
I got it to work, but I had to remove the delay command. Remember we talked last month about using the millis in place of the delay? But what you have to literally do is start inserting a whole bunch of the drive commands, because it needs to be redriven like every 7 milliseconds or something like that. If you read back in the instructions, and I have a link for that on the web page. Let me share real quick. Go back to the web page. If you click on link number 2, a link to the bicolor LED library page. There it is. If you scroll down a little bit, I think I went too far. Here. If you're using yellow, and this is only on a bicolor LED, if you had a separate LED, that's not an issue. You need to call the LED.drive at least every 9 milliseconds so that the library can alternate colors without the flickering being obvious. That means if you use a delay, the LED will freeze in one color until the delay finishes. So what I had to do was, like, basically about every third or fourth line in my code, I had to add this LED drive command right here.
Okay.
So if you try that, just keep inserting it, and then you have to get rid of the delay. Just comment out the delay to test it. You should be able to get a yellow. And you know, what I forgot to mention at the top of the night was if you guys had bicolor LEDs, you could be using them instead of using 2 LEDs like I am right now. The only difference is you'd be wiring a little different than what we're doing right now, but the end result is the same. All the pins on the Arduino, let me just...
If you want, I'll show you mine, Chris. Yeah,
sure.
A little demo, and you'll get a chance to see the bicolors. Let me bring this down here. It's my camera. Okay. This is basically the thing. I modified my code just a little bit from what you have, and so when I change the lights, you'll see an all red for basically the duration of how long the servo takes to switch. And you'll see there it's all red. Now I get a red and green. And these are the bicolors, and if I press it the other way, you can see that delay before it switches over. I don't know. It's hard to tell the difference on the colors of the LEDs, but you can see at that point they're all red. And here's that SIP resistor that I was talking about a little earlier. You can see how it simplifies the resistors by having a simple SIP resistor.
Oh yeah, that's kind of nice. I didn't know they made those. That's awesome.
Yeah, they're actually very, very convenient to use when you have a whole bunch of LEDs that you want to do.
So if
Pardon? I think I just did a search on. I think I probably got them on Banggood, either that or on eBay, and they just came in a packet like this, and there's a whole bunch of them in the packet of different varying amounts, and it was probably like less than $10 for the whole packet.
Oh, nice.
So.
And those are all 8 resistors, or are there different quantities on different ones?
There's these are 2 different values. They have thousands and 10,000 ohm, 470, 4,700, and 47,000 ohms, and each one of those measurements has both 4 pins and 8 pins.
Oh,
you can
nice.
You can see that the on the top there, the 4-pin versions.
Yep.
And on the bottom is the 8-pack. So
very nice. Thanks for sharing. I didn't know those existed. So that's
in fact, you can see I put my own little tag on there with the ratings on them.
Sure.
The different, because they're coded like 102J, and that's a 10 with 2 zeros behind it, so that's 1,000 ohms. And so 103J, because the numbers are too small, or the things are too small to put a full measurement on there, instead of saying 10,000, it's 103. So that's a 10 with 3 zeros behind it to get 10,000.
Well, the nice part about that is they gave you pretty much the right ones for LEDs. So I'd say 470 is a great place to start. I mean, the thousands, if you want it a little dimmer, you go up to 1,000. If you want it a little brighter, drop down to 300. You know, that 470 though is pretty much a good place to start when you're working with, unless you really have a high draw LED or something, you know.
Right.
Which
No,
are
I agree.
sometimes the RGB LEDs can draw a whole lot more than a single color LED, but
Yep.
all right. Well, very good, Dave. Thanks for sharing that.
Okay.
So anybody out there in YouTube land need any help finishing up? Otherwise, I think we're gonna, okay. 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 Yep. Johnny's got a question he says for me. Sorry for the pause there. Go ahead, Johnny.
All right. We got, first off, I want to say, hey to Chesapeake and Ohio Junction. He said this is his first time in here, so hope you enjoy it.
Welcome. I hope we didn't bore you to death. Hope you're interested and you learned something tonight. So
yeah, we got Tab M. He said, if the combinations are always the same, you really only need 2 pins on the Arduino. 4 LEDs might draw too much current, so you would probably need to use Arduino to switch a small transistor.
Okay. That's interesting comment.
Yeah, I think he's
Definitely
talking
food
about,
for thought.
yeah.
Yeah, I know what he's saying, so.
Okay.
And I do agree with him too, that you could get away with the 2, and I was actually looking at doing that myself, except I thought that the current draw would be a little bit too much. I think the highest current draw that you want to draw on any particular output on the Arduino is about 50 milliamps.
I was thinking 40 even, if I remember right. So 40 to 50, I wouldn't go more than 50 though. Yeah.
And I think a lot of these LEDs draw as much as 20 milliamps, so you really don't want to go with more than 1 or 2 on any particular output. But if you ran it through a transistor, for example, you could definitely increase that, get a transistor that's capable of driving 4 LEDs. And transistors are literally a dime a dozen or less. It might be 5 cents for a dozen transistors.
Penny a piece, yeah.
Yeah, not even that. And you could use the signal output to drive a number of outputs that way as well.
Okay.
Any other questions, Johnny?
All right. Okay, so what I'm going to do is I'm going to turn Dave loose with his new invention that he's still just wants to add a few more features to. But this is something we're going to start building in April. And we'll get a parts list out sometime probably in the next 2 to 3 weeks. So that gives you a good month and a half or better, to almost 2 months to get some parts for it. So if you want to build I'll let Dave take it away. And while he does that, I'm going to just set up the joystick and show you how simple it is that you can actually go ahead and download those sketches that I put up there and just test the joystick if you want. So go ahead, Dave.
All right. I just what I've got here is Chris and I went out a number of times, and we've been out trying to find fast clock code or anything for a fast clock, and they just don't seem to be anything out there. And so I decided I was going to have to make a fast clock in order to get one.
And that's Arduino, of course, he's talking about. There's tons of expensive fast clocks you can go out and buy, or you can use the one in JMRI. But Arduino-wise, there's just nothing to be found.
So what we did is basically I used all of the components that we've already talked about before. You can see I've got an standard Arduino Uno. We had a session with our real-time clock, and so I'm using a real-time clock, which you could see on the display right here, shows as 9:10 p.m. And
can you focus that a little better, Dave? Okay, that's just that's good. Then it's just my screen then. Okay.
You could see if I unplug this, it says 9:10 right now. If I unplug it, it goes away. The real-time clock keeps track of that time, and when it comes back on, The real-time clock is now 9:11 p.m., so that didn't change. I have a fast clock over here set up. Right now it's at a 30-to-1 ratio. So for every 2 seconds that passes, my fast clock passes with an additional minute. And it started at 7 o'clock p.m. and so it's under this column. Interesting thing you'll note is that I have this, whoa, through my numbers. Let me reboot. Sorry about that. That's one of the wires went loose, and that's what happened. But we used one of these LED displays before, and notice that that clock mirrors the fast clock on the LCD display, and so we'll be able to put this LED somewhere else out on the layout and have a control panel right here where you can control your fast clock. If you want to change the start time of the fast clock, I got this little dial on here. This is what's called a rotary encoder. Rotary encoder, think of it, it's the same dial that you might have on an AM/FM radio where for tuning, it just keeps going around and around. And you can see as I turn the dial, it's changing the starting time. I rotated right into the AM, and at noon, oh, I did it again. I got some loose wires in here somewhere. There we go. Sorry about that. I do have loose wires in there somewhere, and it wasn't causing a problem before. You press it, you could change your minutes. Oh, did it again. Darn it. I know I got to have, these must be loose wires down there. There we go. That's what happens when you move things around too much. Change your time. Come down here, you can save it, cancel it if you want to go back to what it previously was, but we'll save it. You can see that now it starts at 8:08, 8:09, 8:10, and it changes it up here as well. Right now this code is a little bit on the buggy side, and that's why we're not doing a show on this quite yet. And there's a number of features that I want to add to this. For example, I'm going to call this one the master clock, and we'll go into probably a second session that shows you how to set up using the COM ports on here, pins 1 and 2, 0 and 1 rather, how you can set up a remote LED or multiple remote LEDs all around your layout so that you could have, you know, a number of fast clock displays anywhere and just have one master fast clock at one particular location that you would use for setting it. Bottom line, that's what I've got coming up. The parts, grand total parts in here is probably less than $5, I would guess, because you can get the Arduinos for $2 a piece, and each one of these displays are about $1 or $2 a piece, $5 to $10 in parts and a little bit of code, and you'll be able to have a fast clock on your railroad. That's about it.
That's cool. I'm looking forward to building that one. I had a lot of fun when we did the speedometer, you know, using the digital displays, and even the LED segment displays were, you know, so to have both of them on there, I'll tell you what, there's the code that he wrote. I saw the code last night. You know, that's probably, other than a few variables you may have to change, it's way beyond what I could do and probably, you know, your average guy. But the neat part is the parts are so simple and the wiring is so simple that you just buy the parts, do those couple of wires, and doesn't matter. Dave's going to share the code. You download the code, you have a fast clock. You know, there's nothing elaborate about the hardware on this one. That's the really neat part. It's probably what we built tonight on here is, you know, there's way more parts on that than there,
yeah,
than there is on what Dave's got there. So
you're absolutely correct, because it's, you know, what you're seeing here with wires is it's just wires connecting up the components. You've got my components are the real-time clock, the LED display, a 4-digit or a 4-line 4x20 LCD display, and a rotary encoder, and the Uno. That's it. That's the grand total of parts. And some wires.
Yeah, no resistors, transmitters, diodes, anything. You know, I mean, that's cool. That's a couple of major components, but they're all just a couple simple wires that it's done. Yeah. So,
That's
all right.
exactly right.
Thanks, Dave.
You are welcome.
I'm just going to take 2 minutes before we quit here, since I showed you that code. Let me share real quick again. Or first, Johnny, am I back on the... There we go. So while Dave was busy doing that, it only took me a minute or two to do this. Take the joystick. Whoops, wrong way. There we go. That's it. So I'm just taking this joystick and rocking it back and forth and making the servo go. And what I did was screen share, show you real quick. Back on my website, there was two different link 4 and link 5. There's joystick and serial monitor. The serial monitor just shows you a digital readout on your serial monitor as you move your joystick around, and then the joystick and servo actually throws a servo for you. And that code is very simple. What you see on this screen is the whole code, and this one is actually written for 2 servos. What I was showing is I'm going back and forth, and my servo was going left and right. Well, if you went left and right with the joystick, the second servo would then activate. So it's kind of like a model airplane where, you know, you're actually controlling. I only just hooked up one servo real quick just to show you. So what I did was right here is what they call tilt is one of the servos, and what they call pan is the other. So this is actually set up for like a tilt and pan for a camera if you wanted to. So you go up and down or left and right. So all I did was I attached my servo to pin number 9. You could also patch it to 10. If you had 2 servos, you attach one to 9 and one to 10. And then A0 and A1 are your 2 joystick connections. So that's all it takes. If I go back now and show you the hardware, that's all I literally did was separate these so it's a little. You got your 3 connections on your servo, which is the same as what we did before. 1 to power, 1 to ground, and 1 to pin 9 in this case. If you had a second servo, it would go to pin 10. And then you got your joystick. And on your joystick, there's 5 connections. One of them, which I don't even have connected right now, is if you push down, it clicks. So that's actually a switch. Like if you ever used a Xbox or PlayStation, you know exactly what it is. When you push down, it's a switch you can do on and off. And then as you push left and right or up and down, in this case, when I go up and down, this servo is going. If I had another servo when I went left and right, that one would go. So there's writing next to each of the pins, and one of them says SW, that's for the switch for when you push down. One of them says VRY, which is your Y-axis. One says VRX, which is your X-axis. That was the A0 and A1 in the code. And the other 2 are just power and ground. So all you do is really connect the X to the A0, or let me look in the code real quick. Yeah, X goes to A1 and Y goes to A0. Power and ground. So that's really a super simple connection. It took me like literally a minute to connect that up while Dave was talking. And you upload the code. And so I can think, you know, there's a lot of things you could actually do with this on your model railroad. You know, you'd have to improve the code to slow it down. I didn't bother doing that. I just wanted to quick get a joystick project up and working to see how it worked, because I've never done it before. It's been in my kit for a year since I bought it. I haven't done anything with it, but you might be able to do some really cool animations on your layout with it. Or even if you wanted to use it to throw turnouts or something instead of push buttons, you could just left, right, you know. You could use it in place of any push button or toggle switch or other kind of switch that you can think of. So That's about it. I just wanted to show you that quick, so and the sketches are out there. Go ahead and play with them, and if you have any trouble, we'll certainly take a look at it next time if you want. Otherwise, my plan for next show is to try to do some building lighting and animations, you know, kind of like dusk to dawn lighting or random sequences of different lights in different rooms going on and off. Just, you know, a lot of guys like to light their buildings, and it's pretty neat to see the lighted buildings, but what's even neater is when all of a sudden one light in a room goes off and maybe another one in the room next door goes on. You know, it makes it look like somebody's there. You know what I mean? So you can set up different sequences of how your lights come on and off in different rooms at different times to make it look like a building is actually occupied, not just static with the same lights on all the time. So that's, I haven't worked out, you know, I haven't gotten through all the code that I want to do yet, but sorry about that. If you get yourself, you know, we got a bunch of LEDs and resistors, and sometime in the next week or two I should have it all finished up, and I'll post a parts list if there's anything beyond LEDs and resistors, that any special hardware or something, but I'm thinking most of it's just going to be in the programming, so we're going to give that a shot. We'll probably add a couple switches like a push button or something that's just to turn it on or off, or to change the sequencing or something, but looking forward to that. And if you guys have any other suggestions and stuff that you want me to work on or that you want to try in your layout, like always, just go out and post it up or send me an email, and we'll start looking at it. So until then, I guess I'm going to turn it back to you guys, or back to you, Johnny, and thanks everyone for being here.
Alrighty, let me make sure my mic's on. Yeah, it's on. Also had a comment here from DDA40X Man. Thanks for all the info. Found the STM32s on Amazon, starter kits, and the STM32 videos on YouTube. I'll start viewing the previous episodes of YTMB Arduino sessions. Tab Joe G said thank you. We appreciate that. Like Chris said, put the comments, make your comments down there below the show, and let Chris know what it is you want to see. And
all right. We'll, yeah, thanks guys, great comments.
Switch over here, and want to say thank you to everybody for coming in on the chat tonight, and appreciate it, Chris, for the show, and Dave for coming in helping out. yeah. Anyway, go to YouTubeModelBuilders.com. There you can find the schedules for the Tuesday, Wednesday shows, and those are at 8 o'clock Central, 9 o'clock Eastern time. The Thursday every week show is at 9 o'clock Central, 10 o'clock Eastern time. Also click on the eMag, sign up for a notification when it comes out. Let's see, next show next week, February 13th, it's going to be the Fine Skills Show with Andy, Ralph, and Miles Hale. They're doing the fine scale builds. I think, I'm not sure, but I believe Andy was going to work on some scenery around the kits that they've been working on, so that's going to be a good show there. So I'll see you tomorrow night on the Johnny Mall Train Talk Show, 9 o'clock Central, 10 o'clock Eastern time. So y'all have a good evening, and we'll see you tomorrow night.